Good morning, everybody. My name is Mr. Shrego, and today I am going to be running you through formative assessment 4.2. This is going to be on pages 13 and 14 in your packet. So in here, right, if you've just watched the notes video, the process is going to be almost exactly the same. I'll run through, I'm going to kind of get these set up and give you your answer so you kind of can check if you are right or not. And you'll be able to kind of follow the process along the way. So, let's get started. Now, with these roller coaster problems, the key thing with them is really calculating your total energy at point A and just kind of taking your time to find out all of the information. You need to remember that at the start of every coaster, well, your KE is 0 meters per second. And that's because our velocity is 0 meters per second at point A. Anytime our velocity is 0 meters per second, our kinetic energy is 0 meters per second because, well, velocity is the energy of motion, or kinetic energy is the energy of motion, and velocity is motion. All right, so at point A, the height is 100 meters. This is quite the coaster. We have to solve for PE, KE, and TE, and V at point A. Oh boy. Well, we say solve for V at point A, but we're kind of telling you it conceptually is that we're always doing coasters where at point A velocity is 0. Because our prompt is essentially the same for all of these. In fact, we have a typo right there. For the next one, it should say solve for all that at point B. Our bad. So instead of, just a few typos. And so right here, we are going to be just working our way through these problems and remembering that each one of these connects with the next. All right, velocity was 0. G is always going to be 9.8 meters per second squared. Our mass of our car is 1,200 kilograms. And we don't know the potential energy at point A. We don't know our total energy at point A, so we're going to put some question marks there, right? Writing down our givens, marking our unknowns. And now we're just going to go through and we'll solve for what we can. I know I have mass, gravity, and height. Anytime I have the three of those, I can use my PE equation to calculate my potential energy. PE equals mgh. Plug my numbers in. 1,200 times 9.8 times 100. It's going to give us an absolutely epic amount of energy. That is going to give us 1,176,000 joules of energy. That's a lot of energy. To find our total, well, now we just say TE equals PE plus KE. Our PE was 1,176,000 joules. We had 0 joules of kinetic, so our total energy is 1,176,000 joules. That's going to be helpful because we can copy that into the next part of our problem. Oh no, I lost my eraser. It's one of those mornings already. That's all we had to do in part A is we had to solve for our potential, or in part 6 is we had to solve for our potential energy, and then solving for total energy is also just another important step in that process because we're going to use that total energy at every other point along the way. I know at point A, or at point A this doesn't always seem useful. It's to set us up for the rest of the problem. Because now at point B, we know our total energy, 1,176,000 joules. It didn't change. Energy is never created or destroyed, just transformed. And here, we have the same amount of energy. It was all potential at the start, but now, well, our height is 0 meters at point B. So our potential energy is 0 joules. Anytime height is 0, potential energy is 0. And now we need to solve for PE. Oh, we took care of that. We know our TE because we brought it from the last page, or the last problem. And now we need to solve for our kinetic energy, all right, question mark, and our velocity. Now we know our mass is still 1,200 kilograms, excuse me. And gravity is still 9.8 meters per second. Now, Savvy viewers may have noticed that there's really only two numbers that I could change in here, right? The coaster from the notes is 100 kilograms different from this coaster. The height is about 60 meters different. But once you know the process to these, there aren't going to be any surprises on anything coming up because it's pretty much the same procedure throughout for all coaster problems. All right, so we've got this all going here. I know my total. I need my kinetic energy. I know my total energy and my potential, so I can solve for kinetic using my TE equals PE plus KE equation. 1,176,000 joules of total energy is equal to 0 joules of potential plus all kinetic. So that means that all my energy is kinetic energy right now. If I want to find my velocity, I can write in my kinetic energy now, because I technically found it. And now if I want to know my velocity, I can use that KE equation, 1/2 mv squared, and plug my numbers in. Do my first steps, right? I can multiply 1/2 by 1200 to just get my 600 right there. Just looking for little things I can do to reduce those mathematical expressions. Now, if I want to undo that multiplication there, little division will do us good. Cancels out the 600, gets v squared all by itself, and we find that v squared ends up being, oh boy, a pretty big number. 1,960. Don't make the mistake of stopping here. Sometimes people feel like they're done. They've got a big number. This coaster, it feels like it should be a big number, but we had found a big number for v squared. Take the square root, and that's going to give us velocity, which ends up being about 44.3 meters per second. It's a pretty intense coaster. I'd love to ride a coaster that goes that fast. I miss coasters. They're so much fun. Oh well, there's always next year. If you're taking astronomy or AP or advanced or something. Alright, at point C, our height is 50 meters. Ooh, we've been given some info. We need to solve for PE, alright. Solve for KE, alright. Well, TE we have to solve for, but we carry that over. We know that from the previous problems. It never changes. Hey, check that out. We already took care of one of those. And we need to find the velocity, all at point C. Our mass is still 1,200 kilograms. G is still 9.8 meters per second. And we're just going to go through and we're going to calculate the things we can. And I know I have mass, gravity, and height, so anytime I have mass, gravity, and height, I can calculate potential energy. $1,200 kilogram coaster, 9.8 meters per second squared of acceleration due to gravity, and 50 meters of height. Multiply all those together, and we are going to find that to be about 588,000 joules. Now this is the halfway point, so you can use that half and half trick if you like it. I always just do the total energy step. Our total energy is potential plus kinetic. 1,176,000 joules of total energy is equal to 588,000 joules of potential plus whatever remainder is kinetic. Subtract your 588 from each side. And we are going to get our kinetic energy being equal to 588,000 once you do the math there. Which is still half and half, but helps if you do the steps. Now we need our velocity. We'll do KE equals 1/2 mv squared. 588,000 equals 1/2 of 1,200 times v squared. 1/2 of 1,200 is still 600, so we'll have 588,000 equals 600 v squared. undo that multiplication with a little division. And we're going to get v squared is equal to, about 980. Take the square root to finish it out and get us v. And we get our velocity at that point is about 31.3 meters per second. Not too bad. It's going to be just that same process really for any of these. And if you're like, wait, you move too fast, don't forget you can pause your YouTube video and be like, oh, let me write that down. Or let me check my numbers against that. Where did I make my mistake? That's how I'd try to use these videos. Is if you're in class and you're just running into a little trouble, try the problem, come in here, watch me do the problem, and then kind of, compare. All right, moving on. Number 9, as mass increases, what happens to potential energy? Well, as mass increases, so does our potential energy. Right, our equation's PE equals mgh. It's all multiplied together. So anything in there, right, is multiplied together. So if I make one of them bigger, the other parts, it all gets bigger because it's just straight multiplication. That's a direct relationship. More mass, more energy. This kind of fits my danger test, right? When I think of energy, I sometimes think of the danger test. Something's up high on a ledge. The bigger it is, the more nervous I am about it potentially falling. I'm not really that worried about a little teddy bear up on a ledge falling, but if you make that teddy bear out of, like, lead, I probably am a little more concerned. Make it out of depleted uranium, man, there's some more reasons to be worried. All right, we are now all the way down on page 14. Let's check out number 10 right here. We have a scientist. They're going to the second floor of a building. It's 10 meters above the ground. Sweet. She is measuring the potential energy of 4 different masses. We need to rank the objects from greatest to least in terms of their PE. Well, now, one of the key things to look at here is that the height. That height never changes. It's h equals 10 meters for every one of these objects. They're all going from the same height. Now, the other thing is, those objects are all here on Earth. I mean, it's the same building. So g is the same. And in our equation, PE equals mgh, that means that those two numbers never change, and the only number that varies between situations is m. So that's all we have to look at right here, is because the other two remain the same. All right, well, at point C, our height's 10 meters, our mass is 3,000 kilograms. D, it's 10 meters, mass is 2,500. A, mass is 1,800, height is 10. B, mass is 1,200, height is 10. All right, the heights are all the same. So you just have to look for the biggest mass, because the more mass you have, the more potential energy you have, given everything else is the same. Object C has the greatest mass, has the greatest energy. D has the next greatest mass, followed by A, followed by B. That's all there is to that one. It's all about mass. As the height increases, number 11 now, what happens to potential energy? Well, as height increases, again, it's PE equals mgh. It's all multiplied together, so if height increases, then our potential energy increases. That's a direct relationship. Now, if we look down here about kinetic energy, well, Ke is governed by, number 12, 1/2 mv squared. And these are all multiplied together as well, right? If I increase that mass number, well, then my kinetic energy is also going to increase. A lot of direct relationships in this unit. Lastly, we've got these 4 delivery trucks moving down the road. They are all conveniently driving at exactly the speed limit. No one's speeding, no one's going slow. And so if we're looking at our equation, Ke equals 1/2 times mass times velocity squared. Well, the 1/2 doesn't change, that's just a fraction built into the equation. And the velocity doesn't change either, so that part's always going to be the same. The only number that can vary here is mass, and since this is a direct relationship, the one with the biggest mass is going to have the most kinetic energy. So yet again, object C has the greatest mass, followed by object D, followed by object A, followed by object B. There you have it. That is Formative Assessment 4.2. I hope the video helps. If you're still struggling with any of this, please come to my or any of your physics teachers' ASRs. Ask us to help you out with it. We're usually really happy to have people there. All right, well, thanks for watching.